The fourth topic that we will cover in terms of the ACT exam is something called coordinate geometry. Coordinate geometry questions deal with real number line and the standard XY coordinate plane, what we call the Cartesian plane. They cover number line graphs as well as graphs of points, lines, polynomials, circles, and other curves in the standard XY coordinate plane. They also cover relationships between equations and graphs, slope, parallel and perpendicular lines, distance, midpoints, transformations, and conics. Let's look at our first example of 3, and of course we're going easy, medium to hard. And let's start with an easy coordinate geometry problem. Number 36, what is the distance in coordinate units between the points -4, 8 and 2, 2 in the standard XY coordinate plane? This question is directly relating to the distance formula. So let's review the distance formula here. Distance is equal to the square root of x2 minus x1 squared, and then you add y2 minus y1 squared. In other words, take your second coordinate. Let's just say this is your second coordinate and this is your first. Take your second coordinate minus the first for each x and y. It doesn't really matter which order you go in. I could do left minus right or right minus left as long as I stay consistent between the x and the y values. So what I'm going to do is square root. The x values are 2 minus a minus 4 squared plus, I went this way, 2 minus a minus 4, then I need to do 2 minus 8 to stay consistent. 2 minus 8 squared. Looking at 2 minus a minus 4, double negative makes it positive, so that becomes 6 squared plus 2 minus 8 is going to be minus 6 squared, which is 36 plus 36, and of course you're carrying the square root down with you, which gives you a total of a square root of 72. So your answer for this one is going to be G. That one is the distance formula. That is one you're going to want to put in the back of your brain to remember, because a lot of times the ACT will cover the distance formula. Let's look at 45. This would be a medium. A circle in the standard XY coordinate plane has a center 3, 8 and is tangent to the x-axis. The point xy is on the circle if and only if x and y satisfy which of the following equations. If we have a center of h, comma, k, the center of my circle is a coordinate h, comma, k, and my radius they will give you, then the equation for a circle is x minus h squared plus y minus k squared is equal to the radius squared. In this scenario, I can go ahead and fill in. I know the center is 3, 8, so I'm going to take 3 and plug it in for h, and the 8 goes in for k. So this will become x minus 3 squared plus y minus 8 squared equals, so right now I look at this and I go, all right, well, x minus 3 and y minus 8, I know it can't be either C, D, or E. I'm down to 50-50 chance here between A and B. So what I need to know is, what is the radius? What is this? They never told us. What they did tell us is that the circle is tangent to the x-axis. What tangent means is a circle is tangent to a line if it comes down, hits the line at exactly 1 point. So if I go and quickly just think through this, the coordinate for the center is at 3, 8. So here's 3 up 8. 1, 2, 3, 4, 5, 6, 7, 8. So my center of the circle is at 3, 8. Well, I know that that center or that circle is tangent to the x-axis. So what I'm going to do is my circle would come down, and it would come down like this, hit the x-axis, and go back up. Well, this distance right here then will represent my radius. And that distance, since we went over 3 and up 8, this distance is 8. So I need to go ahead and say that it's 8 squared, which is 64. So my answer is going to be A. In this case, what you want to put in the back of your brain or on your little note sheet is to make sure that you understand the equation for a circle. That's the key one that you want to get out of this. The equation for a circle, which is x minus h squared plus y minus k squared equals the radius squared. And they will probably give you that information within the paragraph. All right, let's move on to number 9. Number 9 is considered, I would consider A to be a hard coordinate geometry problem. Diastolic blood pressure tends to increase linearly with age. Suppose that the average diastolic blood pressure of 20-year-olds is 120, and the average diastolic blood pressure of 60-year-olds is 140. Given this model, what would be the average diastolic blood pressure of 50-year-olds? Some people might want to try and graph this and guesstimate from graphing it. I think what I see is a couple coordinates here. I see 20, 120. And I see 60, 140. And what they're saying is given this model, in other words, we are dealing with y equals mx plus b because it's linearly. So let's go ahead and find our slope. Well, slope is one that they love to put on the ACT, and that's your y values subtracted, y2 minus y1, over x2 minus x1. Some people might remember it as change in y over the change in x. And this is rise over run, just like it's y's over x. Y's and rise rhyme. So I'm going to do y2 minus y1. 140 minus 120 over 60 minus 20. The x is subtracted, but go in the same order. On top, I get 20, and on the bottom, I get 40. So my slope, or my rate of change, is 0.5. So I know this number will go in there. And we actually start our equation at 120. So we can go ahead and put the 120 in here for b. So my equation becomes y equals 0.5 times x plus the 120. And so they're asking for a 50-year-old. Well, what's the average change here? You're talking from a 20 to a 50-year-old. That's a change of 30 years. And my average rate, that's what x is my number of years. So it's going to be 0.5 times 30 years plus the 120. This gives you 15 plus 120 for a total of 135. So I'm guessing a 50-year-old will have a diastolic blood pressure of 135. So my answer would be D. Now there's some other ways that this could have been done. Some people might try some guess and check kind of estimate. Estimating might be a good way to do it. Some people, like I said, might try and just graph it. You've got your XY and graph your 20, 120 and graph your 60, 140. Here's your 120, here's your 20, here's your 60. And then just kind of from there, guesstimate where 50 would be. And this is a sloppy graph, but you can at least use it to kind of take a guess, to give you an estimate of where it might fall. A couple of different ways you can do that one. Either way, these are 3 examples of coordinate geometry.